Welcome to Rani Chemistry classes. In this video, I am going to discuss about the weekend test 1 in first year chemistry, some basic concepts of chemistry. Like and subscribe this channel. First one, the normal temperature of a healthy person is 98.6 Fahrenheit. What will be this temperature in the Celsius scale? We know the relation between Celsius and Fahrenheit. C by 5 equal to F minus 32 by 9. Here Fahrenheit temperature is given. C by 5 equal to Fahrenheit is 98.6 minus 32 by 9. So C by 5 equal to, we will get 66.6 by 9. So C equal to 60. Here by simplifying this we will get 22.3. So C is equal to 22.3 into 5. So we will get 37 degrees centigrade. 5 by 3. So this is equal to 37 degrees centigrade. Okay. So answer is second one, that is 37 degrees centigrade. So this is the relation to calculate relate between the centigrade and Fahrenheit, that is C by 5 equal to F minus 32 by 9. Okay, next second one. In an experiment, the burette reading is reported as 24.5 milliliter. It implies that the burette is graduated to, that means it is calibrated to. Here 24.5 ml means after the first point, decimal point, that is tens are taken, so it is calibrated to 0.1 ml is the first correct answer. First one 1 ml, second one 0.1 ml, third one 0.01 ml, fourth 0.001 ml. Here after the decimal point single digit is there, so 0.1. Suppose if the decimal point after the decimal point we will get 2 digits, for example 24.55, then it is graduated to 0.01 like that. Okay, next. Under the same conditions of temperature and pressure, equal volumes of all gases contain the same number of molecules. So this is first one Boyle's law, second one Charles' law, third one Gay-Lussac's law, fourth one Avogadro's law. So here fourth one is the correct one. Boyle's law, at constant temperature it relates between, that is volume is inversely proportional to pressure. Charles' law, at constant pressure volume is directly proportional to absolute temperature. Gay-Lussac's law, at constant volume pressure is directly proportional to absolute temperature. So Avogadro's law, it relates between the volume and number of molecules. So fourth one is the correct one. Next, fourth one, the atomic mass of one O816 atom is. Here this 8 indicate the atomic number of oxygen, this 16 indicate the atomic mass. So atomic mass in olden days is indicated as AMU. Nowadays it is indicated as U, unified mass. The options given are first one 16 grams, second one 16 AMU, third one 16 U, fourth one 8 AMU. Here 16 is the right answer. 16 AMU. AMU means atomic mass unit. It is used in olden days. Nowadays it is AMU is replaced by U, unified mass. So third one is the correct one. Next fifth one, the relative abundance of chlorine 35 and chlorine 37 are in the ratio of 3:1 respectively. The atomic mass of chlorine is. Here isotopes means having the same atomic number and different mass number. In this case, the atomic mass is calculated as the average of the atomic masses. So that is atomic mass, the sum of the atomic mass into relative abundance by 100 or by 100, or the sum of the atomic mass into ratio by total parts of the ratio. So now I am calculating by using this. Here first one, chlorine 35, atomic mass is 35, so it contains 3 parts, so 35 into 3 plus second isotope is 37 into 1 divided by total parts is 4. Here by adding this we will get 105 plus 37 by 4, so this is equal to 142 by 4, so we will get 35.5. This is the average atomic mass of the chlorine. So first option 35.6, second option 35.5, third option 35.7, fourth option 35.0 unified mass. So second option is the correct one. Next, sixth one, the amount of CO2 produced by the combustion of 8 grams of methane CH4, that is methane is. First you have to write the equation, that is combustion of methane CH4 on combustion means reacts with oxygen forming any organic compound on combustion gives the products CO2 and H2O. Now we will balance the equation. Here carbon is 1, hydrogens are 4, here hydrogens are 2, so kept 2. Here oxygens are 2 plus 2 4, here oxygens are only 2 to get 4 2. So this is the balanced equation. Here the question asking relation between the methane and CO2. Here 1 mole of methane gives 1 mole of CO2. 1 mole of methane gives 1 mole of CO2. Here 1 mole of methane means 16 grams of methane. 16 grams of methane gives how much that is the amount of CO2. Here 1 mole of CO2. 1 mole of CO2 means here CO2 gram molecular weight or molecular weight is 44 grams. Carbon is 12, oxygen is 16, 16 2s are 32, 32 plus 12 44 grams. Here 44 grams of CO2 is produced. In the question they are asking 8 grams of methane gives. 8 grams of methane gives. By doing cross multiplication, 44 into 8 by 16, 8 1 jar, 8 2 jar, 2 2 jar, 2 2 jar. So we will get 22 grams of CO2. So on the combustion of 8 grams of methane gives 22 grams of CO2. Option 1 11 grams, option 2 22 grams, option 3 44 grams, option 4 88 grams. So option 2 is the correct one. Next, seventh one, the number of atoms present in 4 moles of CaSO4 is 4 means CaSO4 means calcium sulfate. In calcium sulfate, atoms per molecule equal to number of atoms per molecule equal to, it contains 1 calcium atom plus 1 sulfur atom plus 4 oxygen atoms, so total equal to 6 atoms. So the number of atoms in calcium sulfate is 6 atoms. Here they are asking the number of atoms present, 4 moles of CaSO4. 4 moles of CaSO4. number of atoms present in 4 moles of CaSO4. 1 mole of any compound contains, that is Avogadro number of atoms. Here in calcium sulfate contains 6 atoms. So number of atoms equal to number of moles into number of atoms per molecule, number of atoms per molecule into Avogadro number. Here number of moles is given 4, number of atoms per molecule is 6. Avogadro number means 6.02 into 10 power 23. By simplifying this, we will get 144 into 10 power 23. In the options given, 1.44 into 10 power 25, 2.88 into 10 power 23, 28.8 into 10 power 24, 3.01 into 10 power 23. Here the relevant answer is first one, 1.44 into 10 power 25, but here we are writing 144. So by putting the point 1.44 into 10 power 25. So this is the correct one. So option 1 is the correct one. Next, 8th one, liquid nitrogen and solid carbon dioxide can be obtained. So liquid nitrogen is obtained at low temperatures and solid carbon dioxide means known as dry ice. It is obtained at low temperatures and high pressures. Options given are high temperature and high pressure, high temperature and low pressure, low temperature and high pressure. 4th one, low temperature and low pressure. So option 3 is the correct one. Next, 9th one, which of the following institutes takes the responsibility of maintaining national standards? Responsibility of maintaining national standards. First one is National Physical Laboratory, Delhi; National Chemical Laboratory, Pune; Electronics Corporation of India, India Limited, Hyderabad; Center for Compositional Characterization of Materials, Hyderabad. Here, the National Physical Laboratory, which is present at New Delhi under the Council of Scientific and Industrial Research, CSIR. It is working under CSIR. Here, this is the main responsible for maintaining the units. So option 1 is the correct one. Next, 10th one, two flasks A and B have equal volumes of oxygen and ozone under STP. Which of the following statements are correct? So generally here A and B having equal volumes means they contains equal number of moles also. Equal, that is according to Avogadro's law, V is proportional to N. V is proportional to N. Here equal volumes contains same number of molecules. V is proportional to N. So equal volumes contain same number of molecules. Here oxygen means O2. Oxygen atoms equal to 2N. O3 atoms equal to 3N. Here 3N is greater than 2N. Here first one is A means oxygen, B means ozone. A and B they are asking. So B is greater. So options given are A and B will have equal number of atoms and molecules. Second one, A and B will have equal number of molecules, but the number of atoms in A is less than B. The number of atoms and molecules in A is greater than B. The number of atoms in A is greater than B. but the number of molecules in B is greater than A. So here option 2 is the correct one. A and B will have equal number of molecules, but the number of atoms in B is greater than A because 3n 2n. Here number of atoms is 3, ozone 3 atoms, ikkara 2 atoms. So second one is the correct one. Next 11th one, which of the following units are not SI units? Here liter. So liter is the unit for liter is not SI unit because volume unit is meter cube, that is meter cubed. Okay, volume unit is meter cubed, so it is not SI unit. Angstrom, 1 angstrom means 10 power minus 10 meters. Here the SI unit is meter, so it is also not SI unit. Nanometer means 10 power minus 9 meters. Here also SI unit is meter. Next, fourth one, degree Fahrenheit. It is used to measure the temperature, but for temperature SI unit is Kelvin. So it is also not Fahrenheit. It is also not SI unit. So not SI units are. The correct answer is first one C only, second one A comma D, third one B comma C, fourth one A B D. So A B D, A B D. So answer is the fourth one. Angstrom 10 power minus 10 meters. Okay. So liter, volume unit is meter cubed. For measurement atom, angstroms 10 power minus 10 meters. So these three are the correct answers. A, B, D. Okay, next 12th one. Which of the following acids are dibasic? Dibasic means which contains 2 OH ions. 2 OH ions. So option A, H3PO4 phosphoric acid, H2SO4 sulfuric acid, H3PO2 hypophosphorus acid, H3PO3 phosphorus acid. Here first one is A, H3PO4. Here it contains H3PO4, it contains 3 OH ions. 3 OH ions. So it is tribasic acid. Next, second one B, sulfuric acid, H2SO4. It contains 2 OH ions. So it is dibasic acid. Next, C, H3PO2 hypophosphorus acid. Its structure is P double bond O, OH, H. Here only one OH is present, so it is monobasic acid. Next, fourth one is given, that is H3PO3. Its structure is P double bond O, OH, H. Here 2 OH ions are present. So it is dibasic acid. Phosphorus belongs to fifth group elements. Its valence is 5. 1, 2, 3, 4, 5. So it always satisfies valency 5. So it contains 2 OH ions. So it is dibasic acid. In the options given, dibasic acids are, that is B and D. B and D. That is the second one. 12th one is second one. Okay, next 13th. Which has the maximum number of molecules among the following? So generally, more the number of molecules, more will be the molecules, because 1 mole of any gas contains Avogadro number of molecules. So more the number of molecules, more the number of moles, more will be the molecules. So first option is given, 13th question, 44 grams of CO2. So here moles equal to weight by gram molecular weight, that is 44 by gram molecular weight of CO2 is 44, that is equal to 1 mole. So number of molecules means 1 Na, Avogadro number, 1 Avogadro number. Next second one, 48 grams of that is 14th one, sorry 13th one, that is second one is 48 grams of O3. So 48 by oxygen atomic weight is 16, O3 means 3, so 16 3s are 48, so it is equal to 1 mole, so that is equal to 1 Avogadro number of molecules. Next third one, 8 grams of H2, that means number of moles equal to weight by gram molecular weight, 8 by 2, here 4 moles, that is 4 into Avogadro number. Next fourth one, 64 grams of sulfur dioxide. So weight by gram molecular weight of sulfur dioxide is 64, so this is equal to 1 mole. So 1 into Avogadro number. Here more the number of moles, more will be the molecules. So here 4 moles are present in option 3. So that is 8 grams of H2. Next 14th one, the number of water molecules is maximum. The number of water molecules is maximum. Here also more the number of moles, more will be the molecules. More the number of moles, more will be the molecules. First option is 1.8 grams. So 1.8 by gram molecular weight of water is 18, so this is equal to 0.1 into Avogadro number. First option. Second one, 18 grams of water means 18 by gram molecular weight of water is 18, so 1 into Avogadro number of molecules. Next third one, 18 moles of water means 18 into Avogadro number of molecules. Fourth one is 18 molecules of water, only 18 molecules of water is there. So less is 18 molecules of water and more is, so that is the third option. That is 18 moles of water is the correct one. Okay. Next 15th one. The number of moles of hydrogen molecules required to produce 20 moles of ammonia through Haber's process. This Haber's process is used for the preparation of ammonia. N2 plus 3H2 gives rise to 2NH3. It is reversible reaction. It is the reversible reaction. NH3. Okay, here the relation is asking between ammonia and hydrogen molecules. Here 3 moles of hydrogen gives 2 moles of NH3. 3 moles of hydrogen gives 2 moles of NH3. They are asking 20 moles of ammonia. 20 moles of ammonia produces the number of moles of hydrogen molecules. By doing cross multiplication, so 20 into 3 by 2, 2 10 jar, so this is equal to 30 moles. First option 10, second one 20, third one 30, fourth one 40. So 30 is the right one. Next, 16th one, the highest number of helium atoms is present in. Same here also, number of helium atoms means more the number of moles, more will be the atoms. So the option 1, first one is 4 moles of helium means 4 moles of helium. 16th one, 4 moles of helium means first one 4 into Avogadro number of atoms. Next, second one 4U of helium means atomic mass of helium is 4. So it contains only one helium. One helium atom. Third one 4 grams of helium means 4 by atomic mass of helium is 4. So 1 mole. So that is equal to 1 into Avogadro number of atoms. Next, fourth one. Here volume is given. To calculate the moles, given volume by 22.7 liters, because 1 mole of any gas at STP occupies 22.7 liters. So we will get 1 by 10 means 0.1 into Avogadro number. Here moles are more in the case of, that is 4 moles of helium, first one. Second one 4U of helium. 4 moles of helium means 4 into Avogadro number. Here 1 helium atom. Here 1 Avogadro number. Here 0.1. So first one is the correct one. Here contains 4 into Avogadro number of atoms. Next, 17th one. A measured temperature on Fahrenheit scale is 200 Fahrenheit. What will be this reading? Will be on Celsius scale. Celsius scale. So already I told the relation C by 5 equal to F minus 32 by 9. Here C by 5 equal to F is given 200 minus 32 by 9. By simplifying this, we will get 93.3 degrees centigrade. 93.3 degrees centigrade. Okay, here first option is 40 degrees centigrade, 94 degrees centigrade, second one, third one 93.3 degrees centigrade, fourth one 30 degrees centigrade. So option 3 is the correct one. Next, 18th one, what will be the molality of the solution containing 18.25 grams of HCl gas in 500 grams of water? So they are asking molality. Molality is indicated by the symbol small m. So weight by gram molecular weight of the solute into 1000 by weight of the solvent in grams. Here weight of the solute is given, question number 18.25. They are given 18.25 by gram molecular weight of HCl. HCl, chlorine is 35.5 and hydrogen is 1. So 36 point, here the value is 36.5 into 1000 by here weight of the solvent is given 500 grams of water. Solvent is water. Here it is 500. So 500 1 times, 2 times. Here by simplifying this, we will get that is 1 m. 1 m, because it 2 times 2 will get cancelled, so 1 molality, 1 molal or moles per kg, 1 moles per kg. So in the given options, first option is 0.1 molality, 1 molarity, 0.5 m molality, 1 molarity. So answer is 1 molality. Molality is indicated by this letter small m. This is capital M means molarity. So it is not the correct answer. This is the correct one. Next, 19th one. Which of the following terms are unitless? Molality means, molality for 19th one. First one is molality. For molality, units are moles per kg or small m. Second one, molarity, moles per liter or indicated by capital M. Next, third one, mole fraction. Mole fraction means number of moles of the solute by total number of moles of solute plus solvent. Here moles has no units, so no units, so mole fraction has no units. Fourth one, mass percent. Mass percent means mass of the solute by total mass of the solution into 100. Here grams will be cancelled, so it also no units. So mass percent has no units and mole fraction has no units. The options given are, first one is, so correct one are mole fraction and mass percent. Third and fourth are present in option 1. So 19th, first one is the correct one. Next, 20th, combustion of 16 grams of methane gives 18 grams of water. 18 grams of water. Okay. In the reason, in the combustion of methane, water is one of the products. Here, first you have to write the equation. Combustion of methane already I have write. Methane plus O2 gives rise to CO2 plus 2H2O. Here 2O2. Okay. Combustion of here 16 grams of methane gives water gram molecular weight is 18 grams. Water gram molecular weight is 18 grams. So 16 grams, 1 mole of methane gives 2 moles of water. 2 moles of water means 2 into 18 grams. That is 36 grams of water is produced. 16 grams of methane produced, 2 moles of water, that is 36 grams of water. So combustion of 16 grams of methane gives means 18 grams is the wrong, because it gives 36 grams of water. So A is false. Next reason, in the combustion of methane, water is one of the products. So these are the reactants, these are the products. So water is one of the product is the right answer. So that for this, both A and R are true, but R is not correct explanation of A. A is true, but R is false. Third one, A is false, but R is true. Fourth one, both A and R are false. So third one, A is false, but R is the correct explanation, because in the combustion of methane, water is one of the products. Thank you. Subscribe the channel.